be examining problem 14.2, backpacks. The data shows us some body weights and backpacks for 8 collected students. They're using the weight of the student as the explanatory variable x and the backpack as the response variable. It would make sense that there would be some relationship, and we would probably expect it to be positive. The more you weigh, the more you're apt to carry around in your backpack. So enter this data into your calculator. Pause the video now and enter this data into your calculator. Alright, here is the scatter plot. As you can see, it is most certainly, remember our acronym for describing our scatter plot, DOFS, direction, outlier, form, and strength. The direction, it is clearly positive. And positive in this context means as the person's weight increases, the weight of their backpack tends to increase. Outliers, no clear outliers. All these points look relatively in the pattern. Form, the form appears to be linear. And strength, I'd say this is a moderate to strong relationship. In a little while we may see our correlation R to quantify our strength. Alright, direction, outlier, form, strength. Positive, linear, and moderate strength. Okay. Here we see we have some computer output. This is similar to Minitab, and we don't have access to Minitab, but we can certainly read our output. A, what is the equation of the least squares line? Remember, our least squares line is y hat is equal to A plus BX. This first column will give you your least squares line. The constant is the y-intercept. This is the value for A. Where the predictor variable intersects this coefficient, this is the slope. So our equation in this situation, A, y hat is 16.265 plus 0.09x, where x is our weight in pounds and y hat is our predicted backpack weight. Also in pounds. Okay, so interpreting these two values, this 0.09, it's close to 0.1. We're saying for every change in y over change in x, we're going to increase 0.1 pounds of our backpack for every 1 pound of our weight. 0.1 pounds, a tenth of a pound. That's like 2 ounces. 2 ounces more of our backpack for every 1 pound of our weight. And this 16.265, this is the value when x is 0. That is, if our body weight is 0, our backpack is 16 pounds. Totally meaningless in context. If your body weight is 0, you are not toting around a backpack. Alright. B, the model for regression has 3 parameters, alpha, beta, and sigma. Can you determine the estimates for alpha and beta in the printout? Alright. Well, alpha and beta, those are the parameter versions of those statistics. So B, alpha is the parameter for y-intercept. Okay. Our estimate is A. In this case, our A is 16.265. Likewise, beta is the parameter for slope. And in this chapter, slope is our big deal. Slope is what we will be doing inference on. We want to do inference on our y-intercept. All right. Our estimate hopefully I can spell estimate. Our estimate is the statistic B, and that's approximately 0.09 in this case. Change in Y, change in X. Change in backpack per 1 pound of body weight. All right. C, the computer outputs S, this is the standard deviation, it's the standard error about the line, of 2.27. This is an estimate of the parameter sigma. Use the formula S to verify the computer's value of S. Well, from our notes here, we learned that S was equal to the square root of 1 divided by n minus 2, 2 degrees of freedom, 2 less than our sample size because we're dealing with paired data, times the sum of the residuals squared. Well, the residual is the y minus y hat, the predicted y. If you use your calculator, you can find these quantities. I'm going into, after performing my regression, I go second stat, and we'll see number 7 is the residuals. Pull that up. Why is it giving me those? No. Second stat, 7 residuals. Then we can see our residuals. Here they are. All right. I'm going to store these into list 3 just so I can see them a little bit better. Stow, second, list 3. Hit enter. Now when I come to stat, edit, list 1 is my original X data, list 2 is my original Y data, and here are the residuals. Let's looking at my graph. Notice the first 1, 2, 3, 4 residuals are negative. If I look at my data in order, 103 is my first X value, it has a negative residual. 109 is my next X value, it has a negative residual. Looking at the graph, you'll see that these first 2 points are below my line. That's what we mean by negative residual. The actual value is below the predicted value. Y-wise is what we're talking about. All right. So going back and looking at my residuals, we have negative 1.161, negative 3.244, negative 1.621. And here you can see we have entered in each one of those values and we're squaring them. When you do that, you yield approximately 30.85. Multiplying that by 1/6 and taking the square root, we get 2.2676. This is the standard error about the line, and that does indeed jive with what Minitab provided us.